All right, we're officially not on break anymore. We got this. I got this. All right, hope everyone had a great break, even though it looks like winter out there for some freaking reason. But let's get back to it. So we're on, I'm sure you all know, we're on the other side of homework 2. I hope it all went well. We'll start grading that now that it's in. I believe the TAs already got started over the weekend. We'll get homework 2 out. Any questions on homework 2 now that it's out that I can be more open about things? Did it go generally well? Hopefully. All right. Oops. I didn't mean to click on it. All right, and we're solidly in the territory of homework 3. I always feel weird. I don't know if this is something I can do to change in the course. But the first week that I'm talking about a new homework, most people are still working on the previous homework. So the last week of content talking about WebSockets, I'd imagine didn't stick all that well. I mean, you can obviously watch the videos, but I'll start off with some review of the last week of content to start getting us all back into the swing of things. So for homework 3, we want to do live chat. That's going to start with live text chat using WebSockets. We need a WebSocket handshake and then sending WebSocket frames over a WebSocket connection to be able to communicate chat messages in kind of real time. I'm going to change the definition of real time today, so I kind of can't say that anymore. But server pushes over to clients using those WebSockets. Then adding some features into that, we talked about multiple features. We're going to listen for disconnections, which is an opcode of 1000, and also handling all the different payloads. There are 3 different kind of types of payload length that we talked about, handling all 3 of those and adding all those features, where Objective 2 is only handling messages less than 126 bytes of payload. Objective 4 is kind of just should be a free one, slapping your database on there. We've been doing databases for a while now, since homework 1. So Objective 4, just like on homework 2, Objective 4 is just slapping your database on there. If you were using your database all along, this is literally free. But if you were using data structures to test Objectives 1 through 3, just change your data structures into database calls and store your things persistently. No new content here, strictly speaking. Except one endpoint where you serve JSON. I don't think that's really overwhelming. If there are questions about that, I'd be happy to take some lecture time and talk about it. But I don't think there's anything wild happening there. No, we did that in homework 1. We delivered JSON. And the big one that we're going to start talking about today, so just to recap, you can do Objectives 1 through 4 right now with what we covered in the last week of content. And Objective 5 is what we're going to talk about all this week. I'll give you a heads up. Objective 5, I'm going to spend a lot of time in lecture talking about WebRTC and how it works. But when you do it for your homework, there's really not much to it. Like when you build it into your server, there's just not a whole lot that you have to do. Most of it's just, or all of it really, is just forwarding messages from one WebSocket connection to another. So there's a lot of logistics to handle with that. Not even a lot, but tricky logistics. It'll end up being like 5 lines of code, but it's really tricky to make sure you're sending it to the right connection and managing these multiple persistent connections concurrently. There are some pitfalls there, and we're going to talk about, and that's what I'm going to talk about next week, is trying to avoid all those pitfalls and give you a bunch of tips and tricks of how to write concurrent code when dealing with WebSockets. But really, you're going to get these 3 types of messages. And whenever you get one of these 3 messages, we're going to assume that there are only 2 clients connected via WebSockets for this to make things simple. Whenever you receive one of these types of messages, forward it to the other WebSocket. And that's it. That's all you actually have to do on your server. So for your homework, the WebRTC stuff is pretty simple, since you can assume exactly 2 WebSocket connections. Even without that simplifying fact, it's not overwhelming to be able to do this. So just a heads up, when I'm talking about WebRTC this week, I'm going to give you lots of background and details on the protocol for your homework. It's fairly chill. It's mostly application of WebSockets is what the homework is. A big part of that is WebRTC is built into the browser. The browser does just about everything for you. So there's not not a ton for us to do on the server side. And that'll make more sense, of course, once we get into some content. So let's refresh this, get some slides. Oh, I don't even remember what buttons to hit. 1 week both feels like forever and not long enough at the same time. All right, so let's start with some WebSocket review. Objective 2 is hard, CSE 312. Don't know how to keep the connection alive and obtain frames. Yeah, Objective 2 is hard. The difficulty curve, I'll say, on homework 3 pretty much mimics and mirrors the difficulty curve on homework 2, and if you want a heads up on that as well, where Objective 1 is, a decent difficulty. Objective 2 is like all of the difficulty. Then Objective 3 isn't too bad. Objective 4 is basically free, and then Objective 5 is not too bad as well, but not necessarily free. The difficulty curve just kind of ended that way. I wasn't planning that. It's just the main topic for each homework is like 2 objectives worth of content. So the first 2 objectives, and then we need those to do anything. So the first 2 objectives end up being the bulk of the difficulty. And then once you have those, the rest of it's just applications. Okay, now that we have multi-part form parsing set up, what can we do with it? Now that we have WebSockets set up, what can we do with it? And what we do with it, the applications just aren't as difficult as setting up the protocol itself. Just the way it happens, just the way the content kind of unfolds naturally. Would it be possible to go over how to send back data to all connected WebSockets? I will do that. I will do that next week for sure. If there's demand for it, I might push that up to this week, because that's what you'll be working on in your homework. That'll be more relevant. Then I can just do some WebRTC stuff next week. So if people want to see that. Why is it that sometimes receive 1024 would sometimes strip 1023 at a time and sometimes 1024 for a buffer? The receive method gives you no guarantee about what it's actually going to read. So there could be a lot of different reasons. If you're using the code from the documentation that has that .strip at the end, it's very possible the last byte is a white space character and you ended up stripping out that white space. Very possible that's what's happening. But in general, you have no guarantee. Like receive of 1024 is going to say read at most 1024 bytes of data from the stream. And there's no guarantee on what's actually being read. There's a lot that can go into what's actually being read, depending on a bunch of implementations. Yeah, exactly, Nicholas has it. But if it's exactly 1023, seems like there could be, if you have that .strip, receive 1024.strip, it's very possible you're removing a white space character at the end, is the only other thing I can think of other than receive has no guarantee on the number of bytes. I do want to talk, since this is a big topic, I'll talk a little bit, just kind of freestyle about how to keep the multiple WebSocket connections. It's going to be different in Python and JavaScript. This is one case where I will show both languages because they're both very different setups, and any language that I've seen has one of the 2 setups. In Python, you're going to, when you establish a WebSocket connection, you're going to enter a well true, is typically the way to do it. Or I should say the way I did it in my code. You enter a well true. If you want to put some other condition other than true, well, opcode not 1000, whatever. But you're going to enter a loop that's going to last the length of that connection. Inside that loop, you're going to have a reference to the handler, to the HTTP handler, which is a reference to the TCP connection, or contains a reference to the TCP connection. So if you're using my code that I showed in lecture, that's what I call the handler. I pass this handler all throughout my code, from the top level receive method to the routers to the paths. All the code out there has access to this handler object, which is a reference to the handler, the top level handler where your receive method lives. And that's where we get access to the TCP connection. You can say handler dot, send all, right? I'm getting my languages mixed. I think it's send all in Python, right? Yeah, okay. Handler.sendAll, and then send bytes to it. So with that handler reference, you can have access to every, to your TCP connection, right? So if we store those handlers from every WebSocket connection in a data structure that's shared in shared memory where all of your handlers can see it, or all of your inside, whatever you have your well-true loop inside, wherever that is, have the data structure accessible to every WebSocket connection, and then you can store those connections. So if you say, okay, we did the WebSocket handshake, I am now a WebSocket connection, go to that, I'm hesitant to use the word global, but go to that global data structure, add my handler to it, because I'm now a WebSocket connection, and now everybody has access to my TCP socket and can now send WebSocket frames over my TCP connection. And likewise, I have access to the data structure of all WebSocket connections. So now when I receive a frame from my user, I can go through that data structure. I can say, okay, let me take a look at all the handlers in this data structure and send this frame that I just assembled to all of these handlers, handler in WebSocket handlers, handler.sendAll, this WebSocket frame, and just iterate over that data structure and send it to all of them. Getting that globally visible I'll be a little careful about how I show this. I forget what I actually landed on for this. I think I used class variables. Yeah. So I used a class variable. So feel free to do the same thing I do here if you just don't want to think about it too hard. But I used a class variable. So in Python, to create a state variable, as I call them in 1.16, or a field, a member variable, instance variable, whatever you want to call them after 1.16, you, in the constructor, say self.variable name and then equals. So this is setting a field of router equal to router, and that's object specific. That's an instance variable. It's specific to each instance of this class, each object of this type. If you want a variable that's at the class level in Python, you declare your variables up here outside of all of the methods. If you put any variables here, they're now associated with the class. They're class variables. In Java, this would be a static variable if you have some Java background. These variables are associated with the myTCP handler class, and there's only one instance of both of these variables. No matter how many myTCP handlers are created, if there could be 1,000 WebSocket connections, there's only one copy of each of these variables, and they're shared among everybody. And then when I'm in my code, I have to open my WebSocket file. I have to be careful here. And then I import that variable. Oh, that's not the right one. Oh, yeah, from server. From server, my server file, or my server package, I'm importing my TCP handler, and then I'll do my TCP handler.WebSocket connections to be able to access that variable. So that's the Python strategy. The other strategy, geez, I almost clicked it. Servers, node, my server. I do the same thing, except I have a variable out here, out at the package level, and store all of those clients in a data structure up here. Socket.on, this callback here for socket.on is called every time you receive data from any TCP connection. So this is a very different setup than the Python setup. And then you can check the connection. This is going to be unique. You take the remote address, which is the IP address, and the remote port, which is the port number. That's going to give you a unique identifier for that connection. And you can say, and you have to ask yourself one very important question when you first receive any message any data over a TCP connection, this is called every time that happens, is this a WebSocket connection or an HTTP connection? It's a very important question you have to ask right off the bat when you're dealing with WebSockets in a JavaScript setup. So you want to get this remote address. There are other ways to do this. This is just the way I happen to do it. Get the remote address or remote port or otherwise any way to uniquely identify this connection and look it up. Say, is this a WebSocket connection? You'll probably have WebSocket WS clients. Is this a WebSocket connection? If it's in this array, then you know that you have a WebSocket frame and you handle it in a WebSocket way. If it's not in that data structure, then you know that it's an HTTP request, which might be an upgrade request to a WebSocket connection, and then you have to add that connection to the list. But you want to ask yourself, is this a WebSocket connection? And go to your data structures and find out if it's a WebSocket connection or not. If it is, then handle it as such. And if you get a chat frame, then go to your data structure, iterate over it, and broadcast it to all of those clients. I believe this is, I should know this better, but I believe this is how Go does it as well. I know it's how Scala does it with Akka, because I've done that plenty of times. And any other language that has concurrency kind of built into it as a fundamental concept, using this event-based architecture, where this event is going to call this function, is going to trigger a call of that function. All right. Oops. I'm spoiling that again. There we go. I'm okay if the lecture question's spoiled, at least today. English Sudoku. I mean that wasn't. I don't know how much I want to say, but that wasn't too much. If you're having trouble following all that in a 300 level class, you got some studying to do. You got some catching up to do. To be fair, we probably haven't talked about class variables in any course that you've taken before, but that concept shouldn't take too long to grasp. Instead of having a variable attached to an object, the variable is attached to the class. It's not too overwhelming, but that might take a little studying. I guess I can see that one. But other than that, there shouldn't be, there's not a whole lot going on there. It's mostly basic programming, I hope. I hope I'm not too off base with that one. Any questions about that? I'm kind of nervous because there are no questions. So maybe it was super basic, or maybe it was just not super basic. It's what? Very difficult? Oh, no. I already forgot everything about this class before spring break. Yeah, it's fair. It's fair. Maybe that was definitely too much for like the first 20 minutes of lecture after spring break. That one's fair. I'll give you that one for sure. All right, so let's. But that might be a great use of our time, just catching up on remembering what computer science is. Does JavaScript have class variable concept? Kinda. So what I did in JavaScript there is created it at the package level. I think JavaScript calls these packages anyway, like at the file level. So now when if I require server somewhere else in my code, I'm going to have access to that variable. I can do server.ws clients. So it's a package level variable, which are kind of like classes depending if you look at it in a certain way. You can also create kind of classes in JavaScript using prototypes. I don't really want to talk about that right now. They're strange. JavaScript actually kind of just doesn't have classes at all. It's all just made up. The latest version of JavaScript does have a class keyword, which pretends to have classes, which is cool. It's nice because you can use the same syntax and pretend you have classes in program the way, in an OOP way that you're kind of used to. But JavaScript doesn't really have classes. It's based on prototypes, which is a JavaScript object, which is just a key value store that some of the keys map to values, and some of the keys, the values are functions, and then we pretend it's an object because it has state and behavior, because some of the keys can store functions, because you just mix the types. Like your dictionary, your key value store can just store any type of value. That type can include functions. You throw functions in your key value store, you kind of have an object. And then with prototypes, you can you can define a prototype, which is going to be a pre-built object with keys and values that automatically exist. Some of those values are functions that just automatically exist. And then you copy all of that into a new object or a key value store and just pretend that you instantiated a class. It's not really classes, but that's the way JavaScript does it. So, does JavaScript have a class variable concept? It kind of only has a class variable concept. Or you can put variables inside a key value store, which JavaScript calls an object. But kind of everything is a class variable. Everything's kind of just floating out at either the package scope or a global scope if you use var. That's why we don't use var. What is MIME type? Thanks, Nicholas. Isn't that somewhat global level variable? 1024. Yeah, so this is kind of a global variable, kind of. But it is package level. So if I want to, in another JavaScript class, use this variable, I do have to import server and do something similar to what I did when I'm doing all this stuff. I do have to import it. So since it has to explicitly be imported, it's not going to have the problems of global variables where we have name collisions. We're not going to be muddying up the global namespace. So we don't have that big downside to it, but we do have package level variables. They are still singletons, so we still have that problem, but if class variables were too much at this moment, all that's going to be too much. So it's not global level because we have specific ways to identify it, but it is global in that it's a singleton. We can only have one of those variables. I can only have one variable named WebSocket connections. So if I want some situation where I want multiple variables that do this, I'm kind of screwed on that one. All right, so let's review some WebSockets. I'm happy to spend the whole lecture in the code if there are questions, but I don't want to. I don't want to do that if there's not too much demand. But excuse me. So let's review WebSockets. So first we had the WebSocket handshake. So WebSockets, I didn't put it in the slides, but just a quick overview on what WebSockets are. You get an HTTP upgrade request. And that's a request to say, hey, let's keep this TCP connection open, call it a WebSocket connection, and then we can send messages back and forth over this TCP connection. WebSockets is about as close as you can get to just using the raw TCP connection. There's a little bit of overhead that we'll see in a couple of slides, that we'll refresh in a couple of slides, but very, very little overhead. It's really just using the TCP connection to have two-way communication. The big feature that we get are server pushes, meaning that the server can send information to clients without having to respond to an HTTP request. So the client doesn't have to say, hey, give me some information. Okay, here's your information. With a WebSocket connection open, the server can just say, here's some information. Here's some more information. Here's some more information. To establish a WebSocket connection, we're going to get a HTTP GET request with these three headers: connection upgrade, upgrade WebSocket, and the most important one, WebSocket key. The first two, I mean, I hate saying this, but you can pretty much ignore. If you're getting a request on your WebSocket path, I mean, it's safe to assume that those two headers are going to be there. To be completely thorough, you should check, but it's not in our testing procedures for the homework. So you know what? There's enough work to do on this assignment anyway. I'm not going to sweat over you not checking those two headers. But this third one, you'd have to check because you have to extract the value out of it. The key will be random. It will be different every single time a WebSocket connection is created, and you have to read this header to be able to read this key and generate your proper accept. These two headers, when you send your response is going to be a 101 switching protocols. You do have to have these two headers, so if you're not checking them when you receive the request, you still have to send them on your response. If those two headers aren't there, or if you spell something wrong in one of those two headers, or anything's just off even a little bit, the client's going to say, no way, you don't speak the protocol. I'm not wasting my time talking to a server that doesn't speak WebSockets properly, and it's not going to allow the connection. Which maybe I worded that a little strange, but if a server doesn't speak WebSockets correctly, a client's not going to establish that connection because it has no guarantee or no confidence that the server will handle frames properly, will send frames properly. If you mess up something with the handshake, it's just going to say, I don't think the server's ready for this level of communication, and just not go there. So you have to have these two headers. Notice the capitalization. That's not a typo. It's just how it is. Upgrade is capitalized. WebSocket is not. If you look at websites and you're getting your test cases, which I strongly recommend for the key and accept, sometimes you'll see these in all lowercase. Check the protocol if that's the case. I didn't lie to you in lecture. Don't worry about that. I mean, sometimes I say the wrong thing. Don't get me wrong, but in this case, usually they're using a different version of HTTP that has all the headers lowercase for whatever reason. HTTP 1.1, you're going to see this exact capitalization. And then finally, your accept that you respond to is generated from this random key. So you're reading this header, appending this global unique ID to the end of that key, taking the SHA-1 hash of that, base 64 encode the bytes of the hash, and set that as your accept header. Very specific procedure. Seems kind of pointless. The whole reason for this is to avoid caching. I don't know, maybe it's overkill, maybe it's not, but it's something we have to do. This way, every request for a WebSocket connection is going to look different with extremely high probability. These keys get pretty long. Very low probability that two of these requests will look identical, which is going to kind of trick any caching that's between the client and the server and make sure that these requests are not cached. We cannot have these be cached because these requests have to make it all the way to the server because the request is to keep the TCP connection open. If there's something in between client and server that says, oh, I saw a request exactly like this, and the server responded with this response, let me not tell the server about this. Let me just send the response because it probably hasn't changed. I mean, HTTP is stateless, and you sent the same exact request. It must require the same exact response, which is nice for things like HTML, CSS, JavaScript, like whatever. Don't bother the server. Don't waste bandwidth at the server, processing power or anything. Let's just send back the response that hasn't changed. With WebSockets, this doesn't make sense because we need to keep that TCP connection open. If the caching sends the response, well, we don't care about the response in this case. The response is just garbage. Like nobody cares. Like, oh, hey, look at this beautiful response that we got. It has the proper accept. Nobody cares. The whole reason for the handshake is to make sure you're both speaking the right protocol. And then it's what happens after the handshake that's important. That's when we're sending the WebSocket frames over the TCP connection. So if your request got cached, you got the right response with the right accept, and then you send a WebSocket frame and realize that the TCP connection was closed because, well, you got the response and the server never knew about it. So the server never knew to keep that connection open. Well, we kind of defeated the purpose. So we need to avoid caching when we're talking WebSockets. Once we have that connection open, we're going to have WebSocket Frames. This is how we're going to communicate. Man, that slide's bright. We're going to, I'm not even looking at it. I can tell it's bright. We're going to get WebSocket Frames in this format, and we're going to send WebSocket Frames in this format. And let's go through this format. The fin bit and the reserve bits, you can assume that these are always going to be 1, 0, 0, 0 for your homework. And if you don't read those and don't check them, I'll never know about it because your stuff might still work just fine. Fin means this is the last frame of this message. I believe it's only used for streaming. Opcode, this one you do have to read. This is the first one you have to read. The opcode for your homework is either going to be 0001, meaning this is text data, or 1000, which means a request to close the connection, in which case you need to sever the WebSocket connection. A mask bit, when you receive frames, this is always going to be 1. When you're sending frames, you're always going to set this to 0. Always, always, always. If this is 1, then there is a masking key of 4 bytes. If this is 0, there's no masking key. So when you're receiving frames, this will be 1, and you need to read the key. When you're sending frames, this is 0, and this doesn't exist at all. You just go directly to the payload. Those 4 bytes don't exist at all. The payload length is either going to be 7, 16, or 64 bits. So if the payload length is less than 126, it's going to be represented in just these 7 bits. And then the next byte right here after payload length will be the first byte of the masking key. The rest of this won't exist. If this is exactly 126, that's our indication that the next 2 bytes are going to be the actual payload length, and we need to read these 2 bytes to get our payload length. If this is exactly, and then this next byte would be the masking key, these 4 bytes. If this is exactly 127, that's our indication that we need 8 bytes to represent the payload length, and the next 8 bytes are all the payload length, and then the masking key after. So we have 3 different situations for our payload length, and then our payload data is masked with the masking key. Each byte of the payload is going to be masked with a byte of the masking key. The first byte of payload masked with the first byte of mask, second byte to the second, third to the third, fourth to the fourth, fifth wraps back around to the first. So if you have your payload data in an array, take the index of your byte, modulo 4, and that's going to tell you the index of the masking key that you need to mask with. Masking is an XOR operation, so XOR the payload data with that byte of the masking key, and that'll unmask the data and get you to your actual payload. All right, so that's your WebSocket review. That's objectives 1, 2, and 3 in just a couple of slides. And I have the opposite warning for WebSockets as I do for WebRTC, where WebRTC, I'm going to talk about it for a while in lecture, but when you do it on your homework, when you do Objective 5, there's not a whole lot for you to do. WebSockets is the exact opposite. I don't have a whole lot to say. That's everything that I have to say about WebSockets, but coding that is a pain. There's a lot that goes into that. In my opinion, it's a good step up in difficulty from parsing multi-part form data and handling that image data. So how much trouble homework 2 gave you, just be ready for that for homework 3. And for what it's worth, homework 4 is easier than I think either homeworks 2 or homework 3. In my opinion, some of you might by the end of the semester say I'm wrong with that, but in my opinion, that's the difficulty curve. It goes up, 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 and then homework 4 goes down. Getting the handshake ain't too bad, but parsing and writing WebSocket frames and working at the bit level does get tricky. It gets tricky. This is one case where if you haven't been writing unit tests since 116, this is a case where it will help you to write unit tests. Even writing my solutions, this is one case where I pull out the old unit tests and make sure I'm testing things. Because firing up your server and just opening up 2 tabs, typing a chat message, and seeing if it appears in the other tab is not a good way to debug these WebSockets. It's going to take you many, many factors, a very large factor times the amount of work it should. I can't put that sentence together. My brain's still on break, too. Can you share what we need to do in Handle, like how to start? Oh my goodness. I don't know if I can. Like Handle, like everything goes in Handle. Or do you mean for WebSockets specifically? Maybe you mean for WebSockets specifically. That would make sense. But everything starts in Handle. Handle is basically your main method in this class. Your handle method is like your main. That's where everything happens. Yeah. Oh, for WebSockets. For WebSockets, if you're using my code for the server, you straight up like have more paths. Let me try to carefully show this. I'm not making that mistake I made earlier in the semester where I showed way too much code. Why do I not have? There we go. Like I just straight up added a WebSocket path using my router. And then inside that path, I have my while-true loop. So if you're using my router, there's really nothing to do in Handle except import this add paths and call it in the constructor. But I straight up have a WebSocket path. And this function has a while-true somewhere in it. This function handles the handshake and then enters a while-true. So don't re-architect everything. The architecture is set up if you're using the one I showed in lecture. The architecture is already there. Just leverage that existing architecture. Talked about all that. All right. Oh, I need to get out of my slides anyway. All right. Let's talk about some good stuff here. I'm going to fire up my server. I showed this on the last Friday that we had lecture, but just to remind everyone what we're doing here. Localhost. Then I have a separate path for WebRTC. So this is a lot what you'll have to put it on your homepage so you can have everything on one big page instead of separating it out like this. But this is roughly what your stuff will look like after having the HTML and JavaScript, adding that into your site. I'm going to start my video, allow it. That's going to get my close-up view here, my different angle. The code right out of the box, when you download the homework and add the HTML and JavaScript, it'll do this right out of the box. Like you can click Start My Video, and it's going to ask you for permission. You click Yes, and it's going to borrow your webcam and show you whatever your webcam sees. And with audio, this will have audio on it. I have the audio muted, so in the HTML for your video, it's automatically muted because usually you don't want to hear your own video, your own audio. We can do the same thing over here. And then so all of that's browser. The browser does most of WebRTC for us. That's all browser. And then start video chat. This is the part where you have to get some server-side code working. I'm going to start my video chat, and you can't really tell because it's the same webcam, but there's a slight delay on the bottom one because it's going through this tab, reading my data, sending it over to this tab, and there should be a very slight delay. Not much. It's hard to even see the delay, but a very slight delay on there. So that's what we want to build, video chat. And this must be muted. Oh, it's just all down. Once I connected the video chat, we should have had some really horrible screeching audio like we did last time. The audio is way down on the room, though, so we didn't get that. So let me stop my server before I forget. So that's what we want to do with WebRTC. So what is WebRTC? Oh, I'm kind of glad I went through the code. I was worried I wouldn't even have enough content for today, but that's fine if this can spill over. So what is WebRTC? Or we might be able to just do it in 5 minutes. What is WebRTC? This is a way of establishing a live streaming peer-to-peer connection between two clients. So that connection that we had, I should have demoed that. That connection that we had was a peer-to-peer connection, meaning that it's connecting two devices, in my case just two tabs on my computer, and connecting them together directly without a server. It's a peer-to-peer connection, no servers involved in the streaming itself. So we want to stream data over a peer-to-peer connection with no server involved. And this is a big reason why there's not a whole lot for your server to do, because it's not even involved in the connection itself. The only thing your server is going to do is negotiate the connection itself, how to establish the connection. So mostly this is used for video and audio. We're not going to differ from that. Video and audio is what we like to stream over the internet. And this is new. Where Websockets, I said was kind of new, but it was in 2011 where it was finally standardized. This is a bit newer. I mean, getting older now, 4 years. But 2018, fairly new, but it has been adopted by the major browsers since 2018. That's when it was that's when it was adopted very widely. So it's been around longer than that, but that's when we first started being able to use it in our apps fairly reliably. As long as everybody had up-to-date browsers, they would be able to use it. So I want to pick out two key terms in this definition that I invented: peer-to-peer and live streaming. So peer-to-peer, two clients, client-to-client communication. We can have a full peer-to-peer network using this technology. If we want a truly peer-to-peer Zoom clone, we could build something like that and not have servers involved in our information at all. If you're interested in privacy, this is a fantastic protocol. If you don't want anybody seeing your data, you don't feel comfortable sending all of your data to a server who's probably storing all that data and tracking you and doing whatever they do with it, and then having your data sent to whoever you actually want to send it to. If you're not too keen on that, WebRTC is a protocol for you. A peer-to-peer connection, you get the servers out of the picture. They're not involved at all. It's client-to-client connections to be able to have this streaming. But for what it's worth, your ISP can still see what you're doing. Somebody still has to actually send the data from your computer to the other computer, from device to device. So your ISPs, any routers on the internet, any tier 1 networks who handle those packets, anybody sniffing packets out of the Wi-Fi, there are still a lot of privacy concerns here. This isn't like the solution, but it does cut the servers out of the picture. So at least there's one less person who can, one less entity that can see your data. This is live streaming, and this is real time. So I said I'm changing the definition of real time today, where WebSockets still have a decent amount of delay. We wouldn't be able to truly stream peer-to-peer video chat over WebSockets. It does still have some delay because, well, I'll talk about it in the next slide. But when you have peer-to-peer video chat or even voice, any even very small delay, I'm sure you've experienced this at some point, even the smallest delay in speech, you're going to have people talking over each other, and you start talking at the same time, and then all of a sudden you're both talking. It's just a pain. If you ever experienced that, I'm sure you have. But even the smallest delay is going to cause that and just completely destroy the experience. You're not going to be able to have even a phone call with somebody if there's a quarter of a second delay. That's completely unusable. You really have to change the way you talk. You have to talk, and then you can talk like they do on walkie-talkies and say over after you're done talking, and then wait for somebody to say over before screw that. So WebRTC actually can't use TCP. TCP is slow. So WebSockets are not really suitable for this because it uses TCP. Now, we love TCP. We've been using it all semester. TCP is fantastic, but it's meant for reliability. TCP is meant to be a reliable connection. If you drop a packet, you request a resend. Okay, I got all the packet. Oh, shoot, I'm missing one. Hey, can you resend me packet 52? You wait for that packet to be sent again, reassemble your message, and then say, okay, I got your message. Here you go. That's what TCP does. It's fantastic because we don't lose any data. That's why we like it. You never have to have some error protection in your server that says, well, if I dropped a packet, whatever. You don't have to do that, any of that. So it's great for reliability. It's not meant for speed. So having real-time, two-way communication, not going to work. So WebRTC actually uses UDP, which is meant for speed. It's a different protocol. It's about as close as you can get to just using raw IP, using the internet protocol itself and just sending IP packets. And if a packet's dropped, you just say, oh, screw it. And you just lose that packet forever. With this, we can get that speed. We lose data, it's lossy. But if you have a live video call, you don't really care if you lose a few frames here and there. It's much better to just lose them than to get them half a second late. Like, that doesn't help us. So we're going to use UDP. I'll finish that up next time. But let's get this out of the way. So have a great rest of the day and see y'all Wednesday.